Hello, my name is Muntasir Arrib, and that is my ID card. So, yeah, 2181799164. All right. So let's get cracking with the code. Wait for it to compile. Yep. And so that's the intermediate CFF drop down. Everything there. So generate allocations. So 166 and hardcore. My algorithms could come up with 273. That's the time, which meets the time constraints as well. So that's my solution. All right, so let's go to AWS now with the auto scale groups. For the auto scale groups, show health of each VM. So greedy algorithm over here, instance management, the greedy auto scale group. So they're both in zone A and B and perfectly healthy. Same should go for heuristic as well. If you go to instance management, and yep, so availability zone is 1A and B and healthy. And then the scaling policy. Okay, so automatic scaling. For heuristic, we've got scale out at 60 and scaling enabled. We've also got for the greedy, the automatic scaling is scale out at 60, scale in enabled. Right, so that's all my scale groups. Now going to launch configurations, show the VM type, which should be T2 micro. There you go. And then we've got for each of the two target groups, show which ALB is connected. Okay. So all of them should be connected to the same application load balancer. So this one's connected to this. Heuristic target, the same goes for that as well. Okay. So show the health of each VM. So heuristic and got it on targets. So both of them are healthy. Greedy target, both of them should be healthy as well. That's about it for the target groups. For security groups, let's go to the security groups. We have to show inbound rules. So application load balancer, HTTP 80 for the heuristic one, HTTP 80 as well. Greedy one, HTTP 80 as well. Okay, so now security groups are done. 2 AMIs. There you go. So the status is available. That's about it. And the application load balancer rules. So finally, we go to the listeners and edit rules. So yep, so we've got 4 rules. If the path is greedy algorithm, forward to greedy target, heuristic target, this one, then we've got response 200, DNS access, and otherwise show an error message. That's about it for the AWS part. Now let's come to my code and show you where the call to the second thread is done. So as you can see over here, there's the asynchronous call, and the client thread waits for 5 minutes, which is 300,000 milliseconds, to waiting for the results. And so, or if all operations are completed, it stops waiting. So I've got it in those catch blocks. So for example, that was the wait, but if completed operations equals to number of operations, it stops waiting. And that's basically it for all of the try catch blocks. Show and explain code to indicate local timeouts. Okay, so the local timeout is in app config. So send config, the 5-minute value is over there, and this catch block handles the local timeout value, local timeout. So that's the local timeout. And for the remote timeout, we've got this catch block that handles the remote timeout. So as you can see, we've got a timeout class in each of the web service interface. So here we have the timeout fault, which is being caught here. So that's how the remote timeout is caught. Also, each of my service takes in a deadline. So there's the stopwatch, and so before it runs the algorithm, if the so before it starts processing it, if it's more than the deadline, which I have set over here. So if it's more than 300,000, it will like throw this timeout exception, which is got over here, which is the remote timeout exception. Right, so so it calls both of the WCF operations, which can be shown over here. So here's where we initialize the service clients, and this is where the event handler is. And finally, we call the operations asynchronously, passing in the parameters and the config values, or what is it exactly? Yeah, config data. All right, so that was it, and thank you very much.